recording now. All right, here we are in 2023, beginning to start the fall check and cleans on air conditioning, on heating systems at this point in time. So this lesson is going to be going over what do we do when we go do a heater check on it, whether it be electric heat systems or gas heat systems. One of the most important things, guys, that I want you to understand when you go do a heater check on a house is that you literally have that customer's life, that family's life in your hands, because we are doing safety checks. It's not like an air conditioning system. On an air conditioning system, if you screw something up, if you forget something, if the system's low on refrigerant, you forget to blow the drain lines, at most they don't have air conditioning or have water problems. Here, if you do your heater check on the system and they have the wrong wire sizes and you're running 42 amps on a 10 kW heat system and they have a number 10 wire in that system, you literally can burn that house down, because they could have a 60 amp breaker with a number 10 wire and you give an okay on this thing because you put your amp probe on it and there's a number 6 wire running from the breaker in the air handler to the 60 amp breaker in the disconnect box. But from there, because you didn't open up the disconnect box to see what kind of wires are in there, somebody ran a number 10 wire from the main panel 60 feet over to that disconnect box, and you got 60 amp breakers, which look fine until you open up the disconnect box. You see, part of your heater check is not just checking the heater, but it's also checking that disconnect box, and you have got to take the plate off of it and put your screwdriver on the lugs to tighten the breakers or the fuse block inside there. You have to see what those wires look like in that disconnect box, because if it is that number 10 wire we're talking about, that wire will start burning because a 10 wire is made to hold 30 amps. It's drawn 42. The breakers are not tripping because they're 60 amp breakers. Well, Jackleg Joe ended up running the number 10 wire. You're doing a heater check. It's your job now to catch what Jackleg Joe did and stop it, because it's your job to say this heater is safe to run for the next 6 months per se, okay? Now we know where we are. It's safe to run for at least 2 weeks, you know? So if that house catches on fire, guys, what is your responsibility?
You're totally responsible.
Do you have liability? Do you have negligence? If that family dies, are the cops coming after you? I know that the lawyers are coming after me because you just did a heater check. I do not know, really and truly, if they come after you personally. I wouldn't want to put myself in that particular position. I really wouldn't. I wouldn't want to just ask the question and try to find out, you know. But checking a gas furnace. Guys, there are limit switches. What is a limit switch? A limit switch is there in order to protect from overheating the furnaces. A rollout switch is there that if ever that flame rolls out looking for oxygen, that flame rolls out and hits a rollout switch and pops the system off, which kills the gas going into your burners, okay? A limit switch is there that if your fan motor stops running, your heat chamber heats up enough to where it kicks that the limit switch off, which shuts the power off to your gas valve, stops the gas going in, which therefore your system will stop running. If you don't test the limit switch and the blower motor goes out and the customer's not home and they're running this gas furnace and they have no blower motor and the rollout switches are not even there, somebody took them off. Somebody jumped off the limit switch. Now the blower motor stops running. What's to stop the burners from running now? Nothing. So that unit will just continue to run, continue to run, continue to run, and end up overheating and overheating and overheating and overheating. Now, the flame is encased all in metal. Will it eventually cause a fire somewhere because everything is getting extremely hot? I would probably think that the house would get hot enough to where it finally kick the thermostat off, because it's just heat rising and it would rise through your duct system into your home, which would hopefully eventually warm your house up enough, because your thermostat is only a couple degrees away, you know? So hopefully it would shut it off like that. But your fire is contained within the heat chamber. But that's why you have a limit switch, rollout switches, and you also have a lot of times you have a limit switch in the blower compartment as well. So if that blower compartment gets hot enough, which the heat would go back in there if that blower motor is not running, that limit switch could kick that system off as well. So you do have several different types of limit switches that can actually shut that gas valve off, okay? So please remember, when you go and check on a heating system, this is for safety. It's not for efficiency in their home. It's not to get them cool. It's literally to keep them alive. Please keep that in mind, because we're going to go over all this stuff, and I want to make sure that when you go out there, you got the right mindset, that before you leave that job, that customer is safe, okay? So the first thing we're going to do, we're going to go over an invoice. So my heating invoice that I have is here. This is my heating invoice. And on that heating invoice, I've got a checklist, which is here for electric heat systems, and then gas systems here. And then the rest of this is your airflow and duct system in here. So yes, we are going to check your duct system when we go and do a heating invoice. Okay? We are going to check some things that I'm just going to say you normally wouldn't check. The first thing we're going to check, which is on the first option there, is it says furnace condition, okay, fair, poor. Now, I've also put together, which in the book here, we've got in here, it says fall check for gas furnaces, and I literally tell you, on number 1, gas furnaces, check the condition of the furnace. Is it rusted, leaning to one side, unlevel, not vented properly, blower doors don't fit on properly? Well, if everything is okay, it would be good condition, it's a new unit, and it's installed properly. If it's fair, it would be system is getting some age on it, but is in good working order. If it's in poor condition, the heater is unsafe to run, burners are rusted heavily, and then doors are missing on the system. Could be the vent pipe is not connected onto the system. It's different types of vent pipe. So basically, I'm giving you a description of what I want you to check and why I want you to check okay, fair, or poor for the condition of the furnace, okay? Each one of these checklists in this list, I literally have in here telling you exactly what I want you to do on that particular list. And we're going to go over all of this in the video so that if I send you out to a job to check on this customer's unit, you literally can refer back to that book and say, well, okay, on number 2, what does he want me to go check? It's the vent pipe. And the vent pipe says on there, you're going to check okay, fair, or poor. Well, what do I want you to go check on the vent pipe? The color of it? How big it is? Yeah, that's one thing. Okay. Where does it terminate? Yep, you want to know when it terminates. When you have an induced draft motor, which is 99% of the furnaces that we have today, I don't even think they make any natural draft furnaces anymore. Now, I'm going to touch on what a natural draft furnace is. A natural draft furnace is a furnace that is designed where you basically have burners, arms up inside of the chambers that the gas shoots into those arms and comes up inside those chambers. The flame inside those chambers comes up through the chambers and then naturally drafts up through the draft hood and then through the vent pipe and then out through the roof. That vent pipe that goes through there has got to be double wall vent pipe, but it does not have to penetrate through the roof. It actually can just stick in the roof jack on a natural draft furnace. Because natural draft means the heat in the attic is naturally going to draft up. The heat from the vent pipe is naturally drafting up. So if that vent pipe is stuck into the hood, it is actually good. Okay? The vent pipe has actually got to be strapped in the attic so that nobody can tear it apart and move it and disconnect it. There's where we have our big problem. We are in hurricane season right now. Okay? What is the biggest problem we have in hurricane season? Roofs being ripped off. When you have a roof ripped off and you have it replaced, what does the roofer do with the roof jacks? They replace the roof jacks on the roof, don't they? If they replace the roof jack and your vent pipe went up through that roof jack with a cap and collar on it, do you really think that roofer gives a shit about the vent pipe, or are they just worried about replacing the roof? Do you think they know anything about your vent pipe and your heating system in that attic there? Or do you ever think they're actually going to climb in the attic to do anything, or are they going to do everything from the roof?
Yeah.
They're doing everything from the roof. They have zero skills when it comes to your heating system. So when you go do a PMA, we had Ida last year right at this time. That heating system has not been checked since Ida. So when you go out there, there's a very strong possibility, if they had a new roof put in, that you're going to go into a brand new furnace, brand new coil, brand new condenser, and it's vertical in a closet, and you go, oh man, that's all I can see. It's brand new stuff up there. There's no use me going look in the attic.
Oh, no, you can't.
So you go, ah, shit on it. I'm not going to look in the attic. I'm just going to put all my vent pipe is okay. When you did that, you just put that family at risk, literally, of dying. And I'm going to tell a quick little story of what happened this last fall. One of my technicians, Chris, they went out to a customer's house. He went out for just a simple PMA, okay? And the customers were having problems with headaches, nausea, just getting sick. And they didn't know what was going on, and they didn't attribute it really and truly to anything, but it was after the storm where they were running their heating system, when he went out for a PMA, and he literally found their vent pipe when they put a new roof on the system, and they broke the vent pipe in the attic. And that vent pipe, all the carbon monoxide and exhaust from the heater was literally just venting in the attic. So as it was filling up the attic with carbon monoxide, that's like parking your car in your living room area and running that car in your living room area, you're eventually going to die. Okay? So when you go to sleep at night, you got 6, 7, 8 hours of sleep. And if it's a really cold night with that furnace running a lot, and you pumping carbon monoxide in the house, the entire family had carbon monoxide poisoning. When he told them that the vent pipe was off and that, you know, we're very lucky we caught this and he repaired it at that time, and then they realized that they were all sick at that point in time, so they went to the hospital and each one of them was diagnosed with carbon monoxide poisoning. He literally saved that family's life. Customer called the next day and just wanted to thank our company, thank him, and really appreciate it and thank them for literally saving their family's life. Guys, it is that damn important. And that's not the first time this has happened in my company where we found stuff like that and literally saved somebody's life. So please, do not take this stuff for granted. Do not take that it looks like it's new, so I don't feel like getting in the attic. No, you got to go look at it. That vent pipe is so important, guys, that it's literally life or death, okay? So on here, number 2, I got vent pipe. It says condition of the vent pipe. Also, the size and installation of the vent pipe is in consideration. Make sure vent pipes are not mismatched or not secured. Make sure that it is through the roof with a cap and collar on it. Okay? Okay means that all the same pipe secure and vented through the roof. Fair means old pipe in good condition and vented properly. Poor means mismatched pipe, wrong size, not vented through the roof, an unsafe application. If you check off poor vent pipe and that vent pipe is unsafe and it is disconnected and broken and the customer says, I don't have the money to fix it, can you leave that system operable?
No.
You cannot. I don't care if they go and turn the gas valve on after you leave. I don't care if they go turn the gas on after you leave. You have got to tag that furnace and put on there, it is unsafe. And you have got to take a picture of it, upload it, write it on your invoice that the system is unsafe to run, shut gas valve off, explain to customer that the system is unsafe, do not run it. Now, you have them sign it, and they go, I'm not signing that. Customer refuses to sign documentation stating that the furnace is unsafe. Customer said that they are going to run the furnace because it's cold outside. They are in the newspaper the next day dead. Can they come back on you now? I'm going to tell you a quick little story. True story, Woodmere subdivision. I went to a customer's house, there's a vertical system in the garage. I turned the furnace on. I started to turn the furnace on. And as I went to go light the pilot, this was many years ago when we had a pilot, we had the light. I literally looked inside the chamber there, and normally you can't see cracks. I could see cracks. I could see that this furnace was in complete terrible condition. This guy had 4 kids. And he says, my pilot keeps blowing out. And I'm like, look at your chamber, man. Your chamber's all rusted out, and it got you can literally see holes in it. So if I light this pilot, man, I mean, I literally could kill your family. I'm like, I'm not lighting your pilot. He goes, well, give me the match. I'll light it. I said, I'm not even giving you a match. I'm not even turning your gas on. Well, I ain't paying you for not doing anything. Well, then you don't pay me. I said, man, don't light that furnace, man. I said, you are going to kill your family. And he started yelling and whatever, you know. He was just one of these guys, and I'm like, I'm telling you, if you light that furnace and run that furnace with your family in there, man, you're going to end up killing your family. Now, whether he did it when I left or whatever, but he didn't pay me, but I wasn't going to light that man's furnace for nothing in the world. Because he was going to kill his whole family if he did this shit. It was that bad. This is one of the worst furnaces that I've seen. It's normally a crack you can barely see sometimes. Most of the time you can't see it. You can actually do tests to find the crack. This one I could see holes. It was really bad. Had a friend of mine had holes in his furnace. When I turned the furnace on, as soon as that blower come on, all that flame started rolling out of that furnace coming up. And it was an old furnace that didn't have rollout switches or anything. So what do? Reach in there and kill the power to the system real quick, which kills the gas valve, which stops the gas coming out. But as soon as that blower came on, it blew all that flame back out at me and started rolling up that furnace. Serious. I mean, you got to think quick, and you got to know what the answer is on that. So my think quick part was, shit, what do I do? Because what's the first thing you think? Get a fire extinguisher. Wait, no, kill the fire first, okay? Yeah, I mean, it's just a reaction to yourself. What are you going to do? A flame rolls out looking for oxygen, and you're standing in front of it, and the customer's standing right there by you. They're freaking out. You're freaking out. He's got to have a little bit of common sense, a little bit of calmness to you, and just go, let me kill the power, because the 24 volts is feeding the gas valve, which is actually powering that thing up. And if you kill the power to that unit, oh shit, they don't have a switch here because somebody disconnected the switch. Take the door off of the blower. Wait, flames rolling up. Well, the blower door is below it. Wait, somebody ended up taking that switch and taping it off. Now what do you do?
Close the gas out.
You're gonna have to. Flames rolling out right back at you then.
You got to put yourself in.
Turn the thermostat off. Turn the thermostat off. Okay. See what I just did? No power, no switch to kill the power to the unit, no door switch to kill the power to the unit. Your first reaction is, I gotta kill power. Well, second reaction has gotta be turn the thermostat off. And then that kills power to your gas valve. Okay, now you need to replace your furnace. How about shut the gas cock off? Should be a red handled gas cock on there.
Some homes you go in, they're not gonna even have one.
They have to have one.
Not cold.
I don't went in some homes
Yeah.
they didn't even have one.
They have to have a gas cock somewhere to shut gas valve off. Okay, because but whip basically that's used for the gas furnace, and it's
Well,
got.
I think that big was in the wrong area. It wasn't in
There you go.
Yeah.
Yeah, and again, that's something good spoken too, that the gas cock should be within reaching distance of that furnace. Okay, it can't be 10 feet over there.
Yeah.
It's got to be here. Okay, if it's horizontal. It's in the closet. It's got to be right there in the closet. It can't be in the attic. I'm gonna go climb in the attic and turn your gas valve off. No, it's got to be right here. Okay. So if you see that, don't you have to say something? And don't you have to give them a price to put a gas cock there now? There you go. Okay. All right. Next thing on your system is your burners. We're gonna check your burners, and your burners. We're gonna check the burners for rust, corrosion, clogs, erratic flames, poor oxygen mixture. I'm recording here too. If your burners are okay, the flame is blue, burners are clean, no blowback from the chambers, which is what I just told you I came across a few times, right? If they're fair, slight rust, signs of age, but still in good condition. Poor, burners are rusted and clogged, poor flames, poor oxygen mixture, unsafe to operate. I had a customer in Algiers I went to, horizontal unit in the attic. Here is one of the ways that you test a horizontal unit in the attic. Okay, so here's the furnace here. There is a little opening, let's just say here on the furnace. So if I did this as a 3D, okay, well then that goes through like this, okay? And inside of here are your burners, okay? So when you get inside of here, if I take a match with an extension, so here's my extension, and there's a little, I'm gonna call it a roach clip on the end of it, and you have two stove matches is what I use. And I will, first thing that I'm gonna do is I'm gonna test this furnace with my limit switch, which is I'm gonna undo my blower motor lead and run the furnace, let it overheat the chamber, get it hot. My blower motor's not running, my limit switch is sitting right here. My limit switch kicks out, then I pull my burners out from underneath that Duquesne furnace, I pull them out, I set them on the side, and then up inside that chamber, I need to find out if there's any cracks in that furnace. Now how I do that, since my chamber is extremely hot right now, because I just overheated my limit switch, right? That chamber's hot like a son of a gun. The burners that I pulled out of there, I use lineman pliers and channel locks to literally unscrew everything and pull everything out and set it on the side. I'm not touching anything, or you could use gloves or whatever may be the case, but it's hot like a son of a bitch. It just got finished overheating. When I do that, I take my vacuum. And my vacuum has got a PVC pipe with an elbow on the end of it. And then I stick that pipe up inside of there and I start banging around up inside there with my PVC pipe, and I'm knocking all of my rust that's in that chamber down. Then I take my match with an extension. I plug my blower motor back in. So when that blower motor comes back on here and it's blowing air across my chambers here, right? Any air pressure in that chamber is going to blow down if there is a crack in the chamber itself. Because if you look at it, if you're behind here and you move the blower motor out of the way, here's what you're looking at now, okay? Now I'm looking through, I am the blower motor looking into my chamber, and this is what I'm looking at. So air is passing here, 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 and here. If there is a crack here, anywhere, then air as it blows is going to blow inside my chamber here. Now remember, inside my chamber is underneath here, because underneath here goes up inside my chamber, because that's where your flame is going, right? Your flame is going inside this chamber right here and then attaches to your draft hood up at the top, so your flame is in here and comes inside of here. The air is passing on the outside of your chamber, which is literally in where you can't see it, right, because it's inside the box. So air pressure gets in the chamber and then blows down inside of here. When I stick that match up inside there, what am I looking for? Here's my match extension. Here's my flame coming up with a point on it, right? Coming back down. There's my nice flame going up inside there. If my flame starts doing like this, what happens? That's air. That means that I am getting air from inside this blower compartment into my chamber, and it's blowing down, which is where my match is at. There's a crack in the furnace right there. Shut the gas valve off, system's condemned. Now, I was telling you I went to Algiers. I did this exact heater check on the system. Went up there, told the customer, a 22-year-old furnace you got up there has got a crack in it. I tested it and you are blowing down, you got a crack inside that chamber. I said, I can get you a price on a new furnace. You can give me a price on it. I don't think I want to replace it right now. I said, now, that's a crack in your furnace. I said, that's carbon monoxide leaks in your house. He goes, yeah, but I got carbon monoxide detectors in every room in the house. I hardly ever run the heater. You know, I like it really cool. I mean, I barely turn my heater on. I think I'll be all right. Again, sir, I'm going to tell you, that's a crack in your furnace. That's carbon monoxide leaks in your house. Carbon monoxide leaks are a deadly killer. It is unsafe to run that furnace. He said, I understand what you're saying. He says, I'm not going to have you at any type of liability. It's my decision to run that furnace. Okay? There's nothing I can do about it. Okay? I wrote it on my invoice. Customer understands there is a crack in the furnace, understands it is unsafe to run the furnace, and decided to run the furnace himself. Okay? So, I leave. Nothing I can do. He don't want to do anything with it, right? Next year, come back, do a heater check again. Went back, I knew right where it was. Boom, found the crack again. Sir, you got a furnace crack as I told you last year. The crack is still there. It's getting a little bit larger. It's really unsafe to run that furnace. It's only getting worse for you. How much is a new furnace? This time he replaced the furnace. It took 2 times. It happens. You know? Sometimes they just don't have the money. No money, no life, whatever. Now, let me ask you this. Because you have a crack in the furnace, does that mean that you are putting carbon monoxide in the house? No. How's carbon monoxide formed? How's carbon monoxide formed?
In the exhaust gas from the furnace.
If you have a perfect running flame, a beautiful flame, then you may not be producing carbon monoxide or enough carbon monoxide in that flame. If you have a bad burning flame, lack of oxygen, you can produce carbon monoxide. Okay? So if he has a clean burner and his flame is nice and blue and pressures are good and everything looks good and he's just got a little bitty crack and he hardly ever runs the furnace. He likes it 60 degrees in the house, 50 degrees in the house. He'll hardly ever run. He might kill the chill. It's his responsibility. I got to tell him he's got a crack and it's unsafe. Is he literally going to put enough carbon monoxide in the house to kill the family? Probably not. But you can't say that. You have to say, I'm recommending replacing the furnace. It's
In that
unsafe.
situation, do you kill the gas and leave that on them, or?
Yeah.
In that situation, I did not kill the gas because I wrote it all in my paperwork. I talked to him about me killing the gas. He goes, no, don't kill the gas. He says, I take full responsibility for it. He says, you can write anything you want on the paperwork and I'll sign it. I said, okay. He took responsibility for it, so that was okay. Now, that made a good point. Do you shut the gas off on everything that you think is unsafe? The answer is no. Okay? If it's really bad, the answer is yes. How do you determine each one? How do you keep yourself safe, the company safe, the customer safe without shutting the gas valve off? Okay. I'm just going to give you a scenario. I've been running my furnace now I've been having this furnace for the last 20 years. I've ran it every year. You're coming in the middle of the winter time. I've been running it for the last 2 months, and it's been a cold winter, and I just figured since it's old, I'd get my heater checked, and you came and checked it out, and you telling me I got a crack in my furnace. Am I going to believe you? That I got carbon monoxide all in my house? I got carbon monoxide detectors. None of them go off.
Hadn't reached the level yet.
Okay? Just happens to be 20 degrees outside today and raining. You don't run the heater, right? Okay, it's 20 degrees outside and raining. I have been running this heater now for 15 years. Get it checked every once in a while. Okay, I've been running it for the last, I'll call it last month or whatever, since we don't have long winters anyway, right? Just so happen to call you up to come get my heater checked. You come out, you tell me I got a crack in my furnace, I got to shut your gas valve off. And I go, bud, you ain't shutting my gas valve off. I've been running this system for, forever. I got carbon monoxide detectors everywhere. And my grandmother is 85 years old. She can't be in a house that's, 20 degrees outside. That can't happen. I'm running my furnace. You can't shut the gas valve off. But you can make a note of everything. And you can put advise customer, do not stay in the house with furnace running for long periods of time. What if you open a window in the house and bring fresh air in the house? Does that eliminate some of the carbon monoxide possibility? It does, okay? Is it still safe? Can you say, go ahead and run it? No, you gotta do everything you're supposed to do. You can't get away from that, guys. You cannot get away from it. Can you get away from writing it down on your paperwork and saying, do not run furnace in big capital letters. Do not run furnace, could cause death. Now, if I wrote that on your invoice and you signed it, am I liable?
No.
What if I put a tag on the furnace too? And you went over there and turned the gas valve on yourself. Am I liable after I left? Does the lawyer argue that you didn't make it inoperable, so I couldn't run it? Maybe an argument, but but you did everything you could do in order to make that system, or make them aware that this is unsafe. System is unsafe. Do not run furnace. And I'd have my guys, if they had a bad one like that, they'd write on there, do not run furnace, could cause death. So I've had customers pissed off because they wrote on the invoice, do not run furnace, could cause death. You're just trying to scare me into buying a new furnace. No, we're just trying to scare you not to run your furnace. If you don't want to buy a new furnace or you want to buy it from somebody else, it's up to you. But yes, if you run your furnace, it could cause death. Yes, it could. Because that's carbon monoxide poisoning. Okay? I'm not playing with that. Okay? So that's your burners, guys. If your burners are all rusted, clogged, poor flames, poor oxygen mixture, unsafe to operate, then you got to make sure you're tagging all that stuff and making sure you're covering our ass on all that shit. Next one, your heat chamber. Your heat chamber. Check chambers for cracks. This can be done several ways. Overheat the chambers on the limit switch. Use stove matches, as we just talked about, on an extension clip. Light the match, put it in the end of the extension, run this match inside the chamber with the fan motor running. The flame should not flicker in the wind. If there is wind, then there is a crack in the chamber. Number 2, you could do a visual inspection with a camera, which they have those snake cameras, right? So on the new InShot burners today, you can run one of those cameras inside there and look for stress cracks. You can look for discoloration inside that chamber to see if you have a stress fracture inside that chamber, okay? The chamber that would allow positive pressure, let's see where I'm at. 2, you could do a visual inspection with a camera, look for stress cracks or discoloration. If there are cracks in the chamber that would allow a positive pressure in the chamber and push the flame out of the chamber, looking for oxygen. We just got finished talking about that. If it's okay, it visually looks good, no flame rollout, nothing discolored inside the chamber. The flame is nice and blue with red flames coming out. No red flames coming out, excuse me. If the heat chamber is rusted, chambers and surrounding areas are rusted, possibly due to water overflowing on the burners or bleach being poured and spilled over the chamber. Old furnaces, rust piled up inside the chamber. That's if you check off rusted on it. Cracked chambers could have a visual crack, or the flame is being pushed out of the burners for positive pressure in the chamber. We just got finished talking about all that. Now, I mentioned on here about bleach being poured on the furnace. Why would somebody pour bleach on the furnace? Well, they're not doing it on purpose. They have a vertical gas furnace. the coil sits on top of the furnace and the drain line comes out, and whoever did it put a T right there above the furnace. So as the furnace or the blower motor is running, they're trying to pour bleach down the drain line because somebody told them to pour bleach down the drain line, and air is pushing up out of the pipe and they're trying to pour it in, and it's splashing all over the heater and falling down onto the burners and the rollout switches and the gas valve and the spark igniter and the flame sensor, and it's all got bleach on it. And what is bleach? It's an acid. It's going to start eating up that whole system. And I have seen burner systems inside there, the end shots and all that kind of stuff, just eaten up with bleach inside there. When you run across that, you can rebuild that whole inside system. More than anything, you got to move the P-trap, the T, don't you? Get it away. Get it away from the burners themselves and put it in a different position so they pour the bleach over here, not on top of the furnace. And then tell them to pour vinegar, not bleach. Vinegar is not an acid like bleach is, okay? A lot of times you'll walk up to those furnaces and those in-shot burners, little jet engines they look like, and there's bleach on top of them that have just rusted those things out. And the rust piles up inside of them, and when that first burner shoots across, that flame doesn't roll out to all three of them. So you can literally call the factory and just get new in-shot burners, and then screw those on there, and then your gas will shoot out and run across easy, okay? If you got bleach all over your flame sensor and things of that sort, then you need to clean it, steel wool. Spark igniters, if it's sparking, it's sparking, but if it's all, you gotta pull all that stuff apart, steel wool it out, and clean all that stuff off of it, If it's old burners that literally stick inside there, you literally should be telling them they need a new furnace anyway, because they haven't sold and made those types of furnaces in 20 years. So if you run across those, they need a new furnace anyway, just out of safety, okay? All right, gas valve is your next. So how do you check a gas valve, guys? You check a gas valve. The gas valve will energize and allow gas, or the coil would be bad. So when you put 24 volts to your gas valve, there's a 24 volt coil. It's a solenoid valve inside the gas valve that just opens up as a plunger, basically allows gas out of it. So if you apply 24 volts and the gas doesn't shoot out, you probably have a bad gas valve. Okay, replace the gas valve. What water column pressure do you have coming out of the gas valve, and how do you test the water column pressure on a gas valve to know, is your gas valve bad or do you have other problems? So here's your gas valve. This is coming in and this is coming out. Okay, got your hole coming in, coming out. Right here, there's going to be like a little port, basically. There's a little screw right there that you unscrew that little screw there, and then you take your manometer. And the one that I have is a field piece, and there's a P1 over here and a P2 over here. Okay? And you turn your manometer on INWC, inches and water column pressure. Okay? So your little reading down here, then you take your hose from your P1, actually it comes from the top, not the bottom, it comes from the top, and this is your return. I'm going to call this return, and then this is your supply. Well, because we are doing gas pressure, I want to measure my supply, my positive pressure. This one's negative, this one's positive. You do not hook the negative up to it, okay? So this is positive on here. When you energize your gas valve right here, here's your coil on it, and which is going to be W and C, energizing your coil. When you energize your coil, there is a plunger basically on here that is going to hold down your gas valve, okay? Or energize your gas valve, which allows gas to flow through your gas. Now, you energize it, plunger comes up, gas is through it. You are now reading the pressure coming out of the gas valve. Coming in the gas valve, you should have 7.5 to 10 inches water column pressure. 7.5 to 10 inch water column pressure, okay? Coming out of it, you should have 3.5 inch water column pressure coming out of the gas valve. Now, where does it go from here? It comes out and literally goes into your burners. There's burner 1, 2, and 3, okay? These are your little jet engines that you see on your burner systems, right? And they are shooting flames into your chamber, okay? When I have my port connected here and I have it on P2 in inches in water column pressure, I should be reading 3.5 inches in water column pressure on my manometer. If I am reading 2 on the manometer there, does that mean that my gas valve is bad? The answer is no. That just means I'm getting 2 inches of water column pressure out instead of 3.5. What if I do have 10 pounds of gas pressure or 10 inches of water column pressure pushing in, but I'm only getting 2 out? Up on top of the gas valve here, there's another screw. It's a regular screw right there. You unscrew that one, and then you stick your little screwdriver down inside of there, and down inside of here is another little port up inside of here with another little screw on it. And what you do is you unscrew it. What am I doing when I unscrew it? I'm actually allowing this plunger to kind of go up higher. Okay? So now my 2 inch water column pressure, I can adjust it to 3.5 now, if the gas valve's good. Okay? So let's just say gas valve's good, and I'm getting 4.5 out of it instead of 2 or 3.5. What do? Same thing. Unscrew this, stick my screwdriver down into it, tighten it up, loosen it up, figure out which way I'm supposed to be going, right? Until I get it to a 3.5 inch water column pressure. The amount of pressure coming out through these burners shooting out makes a huge difference. If I have a 2 inch water column pressure, my burners are going, and you will get to understand the sound of a good shot burner, okay, with 3.5 inch water column pressure. So when it comes on, you're hearing, if it's 2 inch water column pressure, you're hearing, and the flame's going in nice and pretty, but it doesn't sound right. Okay, so if you got a good force of pressure going in, and you'll hear it because 99% of the furnace that you go to, it's the right gas pressure, okay? 1% you may run across that don't have the right gas pressure, okay? If it's 4 inch water column pressure, 4.5 inch water column pressure, you may hear, and that thing's blowing like shit out of there. Now, it's heating that damn thing up fast, man. You need to go, that don't sound right. Do we have to check water column pressure on every single one we go to? The answer is no, we don't have to, okay? Should we? Just for our own enlightenment? The answer is yes. Okay, literally, it takes 2 minutes to hook it up and check it, okay? Should we? The answer is yes. You get to check a few of them, and you know what gas pressure is coming out of that system, and it may be 3.6, 3.2, 3.5. It's running good, the flame's burning good. Do you have to make an adjustment from 3.2 to 3.5? No. Okay. So, I've been on a floor furnace. And you know, in these videos, guys, the main thing I'm going to tell you in these videos is that you will not get in a book, and a lot of times you're not going to get at Delgado's. You're going to get 30 years of experience in this video that I'm doing here, because I'm going to give you stories that I have been across in the last 30 years, all the service calls that I've been on, the problems that I've been across. These are the things that actually mean something when you're going to customers' houses learning this type of stuff. So, you know, stories can ramble on, but they are some of the most important things that if you remember later on, and it really is something that to, you know, not take for granted per se. So, floor furnace. It's a millivolt gas valve. It's not 24 volts at a gas valve, it's millivolts. Okay? We'll explain millivolts later. A millivolt gas valve has 2.5 inch water column pressure, not 3.5 inch water column pressure. So if you've ever worked on a floor furnace or been in a house that have a floor furnace, so a floor furnace is basically a hole cut out in the floor, and then they drop a furnace into that floor and it has a metal grate on the top of it. And down at the bottom of it, you have a pilot that you do a little spark ignition on it, push a button down and the pilot comes out. You light the pilot. Once the pilot's lit, you turn it in the on position. Your thermostat on the wall is millivolts, which then sends the signal back to the valve, which therefore energizes the valve. There is no blower motor on the floor furnace. It is just heat rising from a chamber below you. It's all encased in metal, and then there's a grate on top of it, and you get what's called waffle feet. If you step on that floor furnaces that's 50 years old, okay? Because there's nothing stopping the heat coming from that floor furnace, okay? There are no limit switches in the 50-year-old gas furnaces for floors. There are limit switches in the new ones that we put in today. So if I take a 50-year-old gas floor furnace out and I put a brand new one in today, the customers complain that the house don't get as hot as it used to. Because there's a limit switch sitting in there, and then that flame's running, heats up the limit switch and shuts your system off. And then when it cools back down, it closes again. And then the floor furnace comes back on, and it only allows it to produce so much heat. Whereas the old one that was 50 years old had no safety features on it at all, and they just got hot as a son of a bitch. And you just learned from one time of waffle feet, you don't step on the grate anymore. It's all it takes is one time, and you learn. Unless you're really stupid. Then you get waffle feet for sure. Okay? And some bitches are hot. Grandma had all those in her house. Boy, they are hot. You learn one time. Now, that floor furnace, can it catch a rug on fire?
Yeah.
Absolutely. There's no limit switches in those old ones. That's why they're in houses that have wood floors. Okay? And again, they're all encased in metal. Those floors get hot though. Now, the little rugs. I've seen a bunch of times that those little rugs get pushed over to the floor furnace and catch fire. Or burn up and singe really good. What if your couch is right next to it?
Potential for fire.
Potential for fire. So you gotta look at all that stuff, okay? All right, so we're still on gas valve, right? I get off on tandons, don't I? All right, tandons. Okay, gas valve energizes static pressure 3.5 inches in water column pressure, not high or low. Fair valve, maybe old but in working order. Bad, 24 volts applied to the gas valve, does not open. Too high or too low static pressure, and valve will not adjust. So if I'm running a 5-inch water column pressure out of here, and I go here and I start adjusting it, it don't adjust, I replace my valve. Today's valve are what we call 100% shut off valves, okay? 100% shut off means what it means, the 100% shut off. So now, I'm going to give you some of the old kind of valves that you're going to run across on old furnaces. 100% shut off means that when my spark igniter is sitting over here and it's sparking onto my burner, then I have a flame sensor rod over here sensing my flame. Well, the only way I'm going to ignite this the igniter over here, the way that I'm going to ignite it is I have to shoot all my gas out of this whole system, and as it goes through here and this spark is in here, it ignites this flame, which goes down this little wing all the way across and ignites this flame, and then goes through this wing over to this flame, ignites this flame. Then the flame sensor says, okay, I know I have flame here, continue to run, gas valve. That's today's furnaces right there. If the flame sensor does not sense that there is a flame on the third burner, it will run for 4 seconds and then shut that gas valve off. It will try it again. The induced draft motor runs, pulls in my negative pressure switch. Gas valve energizes when the spark igniter ignites. Boom, shoots out over it. Flame ignites on my igniter. It runs to my second one, it ignites. It runs to my third one, it ignites. It runs for 4 seconds. If the flame sensor does not recognize that there is a flame there because of a bad flame sensor, a broken wire, whatever, it will shut off again. It will do this 4 times. After 4 times, it will shut the system off, and the only way you get the system back on again is you turn the power off and turn it back on, and then you try it again, and it will do it again. How do you now fix the system? You have to test the flame sensor, which we're going to test in a few minutes here. We're going to test the flame sensor and see if it is getting the correct DC amperage. Okay? A second type of gas valve is going to be like an 80% shut-off gas valve, which literally can light a pilot. So it's got a pilot tube coming out of it. We'll call it right here as a pilot tube. So this pilot tube is running down over here to my igniter. Okay? So my igniter would kind of look like this. So here's my gas would shoot through a piston right here, and then my flame would shoot out like this, and then kind of, do like that, and it's a nice little blue flame shooting out of it, okay? So as that little pilot, and the pilot is no more than, say, 2 inches at the very most, 1.5 inches or so, and that little pilot is shooting out across my flame. Once the pilot ignites, there is actually then a flame sensor on the pilot that says, okay, my pilot is lit now, so now it's okay to send the gas, the other 80% of gas through. Remember, my first open was only open on a pilot tube, which is a little silver tube about the size of a pencil. If you have to take apart that pilot tube, I am going to give you some tips here that will save your ass if you remember them. You won't remember them the first time. You're going to have to replace the gas valve, is what you're going to have to do. Then it will cost you a couple $100, 2 hours of your time, and then you will go, I think Eric told me something about that. Let me go watch that video again. And here's what it is. That little pilot tube has got a brass fitting on it. Okay? So it's a little silver pilot tube with a brass fitting. It's got a, can't think of it,
Flare.
it's like a flare. It's not a flare, it's a damn little dial on the end of it, and it released, I can't think of the damn name for it anyway, I'll think of it in a second. But as you screw the brass fitting on, the little brass piece on the end of it flares out and basically grabs the little silver tube and basically crushes the little silver tube and stops gas leakage. And it disconnects from the little brass piece. So that now I can unscrew the brass piece, and that little brass piece inside that disconnected is clamping the silver tube. Okay? Now, here's where the experience comes in of how I've screwed it up and how I don't screw it up anymore. And every time I tell somebody to do this, they will screw it up at least once. When I take that pilot tube out, it unscrews, so the brass piece continues to roll, and it will slide up and down on that little silver tube, okay? A ferrule, that's what it is. I knew I'd think of it. So the little brass piece connected to the little ferrule is connected to the little brass piece. When you screw it in, the ferrule ends up flaring or crunching down onto the silver piece, and there's where it stops your leakage and everything and adheres to it. So as I take the pilot tube out, so I go to start this system up, and my pilot is not having a flame come out of it, or it's a very, very, very little flame, like barely coming out of it. So I know I probably got a clog in that pilot tube, right? Well, how do I clean the pilot tube out? I'm going to give you a simple way to clean it out. You realize this ain't but like a gnat's fart of gas pressure coming out of here to blow out of here, right? So you take this out of here, and then you take your dry nitrogen tank. After I pull it out, I put my dry nitrogen tank and I blow it through there. It's just a piston. It's just like a little bitty pinhole in a piece of metal is all it is. You're not going to blow a big hole in it. You're just going to build up pressure on it in order to force more pressure out the other side. And if there's any crack in it, it's soot. So you can easily blow the soot out with a high pressure on dry nitrogen, right? So I just hook my little dry nitrogen tank up to it, and I go, and I just blow it out. And then now, here's where the part comes in on the experience. When I go put that silver tube back into my gas valve, remember, when you loosened it up, it literally, you could grab it with your finger and loosen it up and take it out. When you put it back in, this is where the experience comes in. When you put it back in, you have to wiggle that silver tube just in the correct position to where you can still tighten it back up with your fingers. If you put it in and you can't tighten it up with your fingers, you are cross-threaded. So if you grab your little crescent wrench and you start tightening it right there, you just screwed up the gas valve, because the gas valve is going to cross-thread, not the brass piece. So now you gotta buy them a new gas valve, because it will not go in now. So the most important thing, as you're putting it in, you keep wiggling that tube this way, that way, this way, that way, this way, till you finally get that thread just right and it goes in with your fingers. If you can't get it in with your fingers, do not put a wrench on it. You will buy them a new gas valve. Trust me, I have done it. The other kind of gas valve will be a pilot, a thermocouple gas valve, whereas there's a thermocouple coming off the top of the gas valve, okay? So, boom, you got a little deal coming up here, and then there's a thermocouple that runs over, and there's your thermocouple out here. You literally take the little knob here, and you push the knob down, and you put it in the pilot position. As you put it in the pilot position and you push it down, it allows gas to flow through here. You light your pilot with a match. The flame comes out, hits your thermocouple. The thermocouple heats up, gives your resistance back, holds the gas valve down. Okay, because as you're pressing this down, it's allowing this plunger down here to literally release that gas valve, but it's not going to allow it to come out until you turn the gas valve in the on position and energize the gas valve, okay? So, I light my pilot. After I light my pilot, I let my little compression thing up, and then after I let it up, my pilot should stay lit. As it stays lit, now I can turn this knob into the on position. When I turn it into the on position, then I can apply 24 volts to my gas valve from my thermostat by turning my heat on. It brings 24 volts to my gas valve, which then brings the plunger up, allows gas to flow through. Now I got gas going into here. It lights my pilot is already lit. Gas shoots out, lights my burner. My burners go across, light each one of them. And then my flame sensor, which the old ones don't have flame sensors on it. So your only flame sensor is your pilot, your thermocouple. If your thermocouple is not lit anymore, is not working, then nothing will work. Okay? If that thermocouple is bad, that's your flame sensor, remember. It's telling you they have a pilot there. If there's no pilot there, gas valve won't work. That's simple. Okay? So that is your flame sensor, the thermocouple. They only cost like, they used to cost $2, they're probably $22 today.
15. Got a quick question.
Yep.
At one time, like you're talking about the pilot thermocouple, that's all they had on hot water heaters and central heat
Still
systems.
today, hot water heaters only have a thermocouple on, you just light a pilot.
Okay.
Same thing, there's no change in that because there's no voltage going to that furnace. And all a thermocouple is doing, guys, is just giving flame rectification, that flame is there and allowing that gas valve to energize. So when you turn it into the on position and you take your gas or your thermometer for your water heater and you turn it into hot, it then closes the circuit and it allows the gas to energize on your hot water heater and turns it on, okay? If you take a millivolt gas valve, okay? Now, a millivolt gas valve is going to be one for a floor furnace, okay? So, inside there, you have 3 connections for your wires, okay? And then you have a pilot generator. And your pilot generator will go here, and then you have two wires coming down. One of them, they're actually connected right here, and then they branch off, okay? And then one will go here, okay? Then from here, it's gonna go with a wire coming up to your thermostat, and then back down, we'll jump over the wire there, and back down to the other side. That's a millivolt gas valve, okay? You light your pilot, your flame comes over your millivolt, your pilot generator is what it's called, a pilot generator. Your pilot generator heats up, it produces millivolts. The millivolts therefore energize your gas valve, which say, hey gas valve, allow your gas to continue over my pilot. So it's just like this gas valve. You have a little compression on it, you push down in the pilot position. When you do, it allows gas to come out, right? In order to shoot your flame out right here. Flame shooting out over it. Pilot generator heats up, produces millivolts, sends millivolts back to your gas valve here, energizes your gas valve here and says, okay, continue shooting gas through here.
Same as a flame rod.
Pretty much. Then from there, you turn your thermostat on, which is a normally open switch because you put it in the off position. You turn it heat on, it closes the switch, sends voltage from here to here, which comes over here, which your coil is now between here and here, which energizes your gas valve and allows gas to come out for your burners. Simple. Just simple, 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 simple. Okay? Yet, they're so difficult to work on because they're a pain in the ass and they're underneath the house and nobody likes working on them. But technically, they're simple.
Those are usually on floor furnaces.
Yes. Or wall furnaces.
Or wall furnace. Okay.
Yep. That's the exact setup that you're going to get. Now, in between here, can you have a limit switch?
Yeah.
You could.
Yeah.
Like wall furnaces will have limit switches. Again, 50-year-old wall furnaces, no limit switches. Today's, they kicking off. You know, they're only going to get so hot today, okay? All right, next one. We are looking at flame sensors. Flame sensor, guys, one of the most important things. The flame sensor senses the flame and produces DC current back to the board for flame rectification. It measures these amps in microamps, measured by removing the wire lead plugged into the flame sensor and putting your lead from your meter, one on the flame sensor and one on the wire tied into the flame sensor, usually orange. So, you go to this flame sensor over here. Here's your circuit board right here. The flame sensor here is sticking out over your last burner. So if your pilot is over here, your spark ignition's over here, your last burner will have the flame sensing rod. It is an orange wire that goes and ties into your board. It is a flame rectifier. There is not 24 volts going in there. It's DC amperage that you are actually measuring from here because it's actually sensing a ground with your flame rod. So you disconnect the flame rod or the wire going to the flame rod. You take your meter here, okay? Here's your amp probe, right? And you take one lead and you put it here. That's your red lead, we'll call it. And then your black lead, you're gonna tie it here, all right? And you're gonna put your meter on DC. And you are now going to be reading like 10 to 11 DC amps. And when you run your furnace, that furnace will continue to run with your meter connected on here, and it will continue to run. And it will read your DC amperage on that flame sensor rod. And if that flame continues to run, and you're drawing 10, 11 microamps on there, your flame sensor is good. If it runs for 4 seconds and shuts off, and you're reading 5 DC amps, it's your flame sensor rod. Replace your flame sensor rod and you're probably going to be okay. If you're reading 10, 11 DC amps and your system runs for 4 seconds and shuts off, it's not your flame sensor rod. It's probably your circuit board now. Now you replace your circuit board. But years ago, man, we didn't know how to test the flame sensor. I'd ask everybody. I mean, we're talking 20 years ago, you know, when all this shit first came out. Nobody knew how to test a flame sensor. Seriously, nobody knew how to test it. Everybody I asked, nobody knew how to test a flame sensor. They go, they're only $2, replace it. See if it works. Or bring the circuit board with you. Test the flame sensor first because it's $2. If it don't work, replace the circuit board. That was the answer back then. Okay? So what is another kind of igniter for your system? And that would be called a glow coil. A glow coil, you apply 120 volts to it. It basically heats up like a lighter, like a heating element, and then gas shoots out over it and that ignites the flame, which we'll go over that in a minute as well too. Okay? So, for your flame sensor. Okay, flame sensor reads 10 to 11 microamps and is clean. Anytime you go to a PMA, guys, you got to pull a flame sensor out, you got to put steel wool on it. And you got to clean the oxidation off of it, okay? If it's oxidized, it may not create that DC amperage. Oxidized, this will become the most, oxidized, okay. This would be most flame sensors you come to, most of them are going to be oxidized. That's what I'm saying in there. Clean with steel wool. And then bad, does not produce microamps, broken ceramic on the sensor itself. If you got broken ceramic on it, just replace it. It's bad. End of story. ID, induced draft motor. This motor pulls in the negative pressure switch through a tube connecting the two. The motor is powered by 110 volts. There could be debris inside the housing of the motor from installation. Remove the vent pipe, run the motor, see if anything blows out. The motor is okay if the motor runs, pulls in the negative pressure switch. It's rusted if the motor is rusted. If it is very probable that the inside is corroded, remove the IDM and check the inside for rust and debris. Also, where the tube is connected to, you also can pull the tube off of the induced draft motor, take a little piece of thermostat wire, stick it in there, and make sure there's nothing clogging up that hole as well. Okay? But in the past, not today's furnaces, but in the past, they used painted metal material that would heat up and all of the paint would actually come off inside the induced draft motor. They used a certain metal on the blower motor itself on the induced draft motor, and the blower motor would literally completely just corrode and fall apart. Like you pull it out and there's no blower wheel.
From the paint?
From the type of metal they were using when they first came out with all this. You know, with engineering, you would think that they would figure all this shit out before they put it into production for years, and then we gotta pull all that shit apart. I mean, literally pull little blower wheels out and there's no wheel left on it. Like
You'd think that they would test it.
you would think that when they're engineering this thing, they go, okay, we're gonna use this metal that I don't know if it's gonna last like a long time or not, you know? I mean, we don't know if it's really gonna rust. Well, why don't you try it first for several years, then put it in production instead of putting pieces of crap out on the market that we gotta tear apart and replace all the time. So today's blower motors, comparative to the old ones, it's completely different. You'll have a plastic case, a hard plastic case, or a metal one, you know, aluminized metal. I'm telling you, the other ones would just rust out, man. You take the induced draft motor off and there's no blower wheel. It just totally rusted. It's all falling apart. Induced draft motor is okay. Motor runs, pulls in negative pressure switch. Rusted if the motor is rusted. Very probable that the inside is corroded and remove IDM. Check the inside for rust and debris. And bad motor does not run after applying voltage to it. Next thing is your negative pressure switch. negative pressure switch is normally open switch, closes from the induced draft motor running and pulling in the switch. Switch closes upon rise in water column pressure created by the induced draft motor closing. Inches in water column pressure is listed on the pressure switch, measured with a manometer hooked into the IDM. Okay, close when IDM is running, no problems. Open, bad switch, will not close. Verified with manometer, measuring the inches in water column pressure above the closing pressure that's labeled on the negative pressure switch. So if your negative pressure switch says negative 0.3 inches in water column pressure, and you test the induced draft motor with your manometer, so here's your induced draft motor, okay? Here's your little blower wheel inside of it. Right here is a little tube, and that little tube comes out, and it comes into a negative pressure switch, okay, into that tube. And then there's 2 wires coming from it, and this is going to your circuit board. 24 volts will go into your switch. When the switch is normally open, it will close when it's sucked in, and then 24 volts will then go this way, okay? When that circuit is closed, it will then allow more things to happen with your furnace, such as the spark igniter will start sparking if all of your limit switches are all closed. If all of your limit switches are not closed, you will not get a spark igniter because the system thinks that it has too much heat. The blower motor will run, the induced draft motor will run, and you will get no heat, you will get no gas valve being energized, you will get no spark ignition, okay? If the negative pressure switch does not close, nothing else will happen other than the induced draft motor will run. Blower motor may even come on because it may be thinking that, hey, I have a safety switch here, maybe I got too much heat, let me turn the blower motor on too. But if the induced draft motor does not close this negative pressure switch, nothing will run. How do you test this? You read the negative pressure switch, and I am making this up and saying that we have a negative 0.3 inches water column pressure. If this induced draft motor pulling in, you pull the tube off of here. You take your manometer over here. You got P1, P2. P1 is your return, which is a negative pressure. P1 will go and connect into here. This says negative 0.3. I am reading on my meter negative 0.5. If I'm reading a negative 0.5 and I'm supposed to close in negative 0.3, I got a bad switch. If I'm reading a negative 0.1 and my switch is not closed, I have a clog somewhere in this tube. Or I have an induced draft motor blower wheel that's corroded down to nothing. Or I have debris sitting inside of this induced draft motor here, which is not allowing a negative pressure in there. Another story. Love these stories, don't we? It's like my kids telling bedtime stories here. Brand new furnace. Old man installed it, been in the field for many, many years. Lady called me up on a Saturday in Destrehan. Got one of my friends installed a furnace for us, and he just cannot figure out why this furnace will only run for 3 or 4 minutes and then it'll shut off. It'll fire up and it'll run 3 or 4 minutes and then it'll keep shutting off, keep shutting off, keep shutting off. I said, well, I can figure it out. I said, but you know, here's my service fee. Okay, come on. So I went over there, turned it on. Burner would light up, induced draft motor comes on, pressure switch pulls in, gas valve energizes, system's running. Okay. I sit there for 2-3 minutes and all of a sudden, boom, shuts off. Spark igniter comes back on again, lights back again, burners are running again. Runs for 2 or 3 minutes, shuts off again. Kept doing that. I said, okay, something is shutting my gas valve off very quickly. So what I did was I put a meter right here on this negative pressure switch. And I ran it again. And as I ran it again, I'm reading 0 because my switch is closed, right? And as I'm watching my meter, 3-4 minutes goes by, finally, burner shut off again, and I read voltage for that long. I went from 0 to voltage for that long. My negative pressure switch opened for that long, which just shuts your system off, is all it does, right? Lets you run it again. I said, okay. I took my induced draft motor off. I looked in the inside of it, and there's a 7/8 copper coupling in there. Put my induced draft motor back on, put my vent pipe back on, turned it back on, boom. Ran fine. A 7/8 copper coupling was up inside there. And that was causing turbulence up inside that induced draft motor, which will not allow my negative pressure switch to continue to be pulled in. Okay? So, induced draft motors are very important. There's your start of the system. Negative pressure switches is a safety feature. What is your induced draft motor doing? If you go to your chamber, guys, here's your chamber, okay? And you got your burners up inside of here, right? Okay, we'll just draw 2 of them. And your flame is coming up inside here, or let's do a different one. Let's do your chambers today as opposed to yesteryear's chambers. I'm just showing my age, nothing more, nothing less. All right. So if you look at a side view of a chamber, which is going to be a hole, there's your side view of a chamber, which goes into a box up at the top. Then you'd have another one right next to it, and there's your burner coming around through here, right? Comes out and then comes up top, all right? And it's going into your box up top. That box is where your induced draft motor is actually tied into, and it's sucking from here, which is therefore creating a negative pressure through here, and on the other side of here is what? Is your little in-shot burner, isn't it? Okay? So here's your gas shooting out here inside your in-shot burner, right? Inside those chambers. Bringing gas flow through into the housing of where this induced draft motor is attached to. It's sucking through here, which is creating a combustion air sucking in through here, plus sucking the gas in as well. When it ignites from your spark igniter right here, now it ignites and everything's burning nice and pretty up inside there. The heat goes through, goes into this little collection box here, which induced draft motor is running and throwing up your flue. If there's a bird nest in your vent pipe, it doesn't allow the air to come out, which therefore your negative pressure switch will not be pulled in.
You got a rollout switch, go trip.
No. Because your negative pressure switch is not going to allow the burner to come on. Okay? There could be a bird's nest, which I've seen before, inside the induced draft motor, because a bird gets in the vent pipe. A little sparrow gets in the vent pipe some kind of way, shape, or form. It's about wasp. Wasp nest. A whole bunch of wasp nests I've seen up inside there, okay? You take the vent pipe off, you look inside there, you turn your fan on, and sometimes it blows wasp nests out of it, dirt fibers out of it, whatever, okay? You gotta make sure all that shit's clean, all right? As it's blowing that gas through that chamber up through there, that pressure as a positive pressure in your vent pipe is creating a negative pressure in this hose to pull in your negative pressure switch. On old Bryant furnaces, there used to be where your vent pipe would connect right here. Here's your vent pipe. There used to be like a little piece of metal coming out right here, and there was a flame, a temperature switch, a limit switch right here. So if you clogged up right here, what happened? can't go this way, it goes this way. It heats up this little switch, and it would shut off that switch. And that would tell you that your vent pipe is clogged up some kind of way. Okay, that's the old school one right there. Alright, limit switches. The most important part of a gas furnace is your limit switch, because your limit switch allows or does not allow the furnace to run. If your system overheats, if you turn your blower motor off, and you have to test your limit switch. How do you test your limit switch, guys? You disconnect your blower, right?
Yeah.
In the heating mode, and then you run that furnace with no blower motor running, and you let it run until it kicks the blower off, until it kicks the gas valve off. Now, after it overheats, then you have to turn your blower motor back on and allow it to cool down and allow it to reset. This is something different that I want to do this year that we've never done before, but I want to now test the CFMs in cooling mode. So on that gas furnace, you are going to now take the blower speed that's in the cooling mode. I'm going to call it the black wire on your fan motor, on a split capacitor motor. You're now, going to hook that wire up to your lead on your circuit board that says heat, and you're going to remove, I'm going to call it the red wire, which is low fan on your heat, and you're going to let it dangle. After I overheated your heating system, then I'm going to go ahead and turn that heater back on, but in high speed now, because that is whatever speed that air conditioner was running at is the one I am using for the heating speed now. When we do that, now I'm going to let that furnace run. It's in high speed now, which the air coming out is not going to be as hot as it is if it was on low speed, but that's perfectly fine. That's what I want it to do. While this furnace is running, I'm going to go ahead and I'm going to blow my drain line. I'm going to check my return air, make sure there's no return air leaks. I'm going to go look in the attic, and I'm going to make sure that my ducts and my collars and my vent pipe and all that stuff is in good condition, not falling apart, and everything's good. The insulation in the attic's good. If there's an attic staircase that hangs down, we need an attic staircase tent. Do they have a UV light in the supply plenum? I'm going to make a note of all that stuff and do some of my paperwork to make sure I'm checking everything I'm supposed to be checking. Now, 10-15 minutes has gone by. My furnace is running after I have overheated it. I got it running in the heating mode. I got my cool speed, whatever speed that one is. I tapped it into my heater speed, and I am running the furnace in the higher speed for cooling. Now I'm going to go check my return air temperature with my laser. I'm going to go to my supply air temperature, and I'm going to check that as well. I'm going to get my temperature differential between the two of them. Then I am going to go to my Covern's Connect app, which you should have on your phone. If you go to the App Store and go to Covern's Connect, you can literally get into the app and use username and password that I can give to you, which is, I'll just tell you on here on the video, I believe it's eGuillory@TaylorTylerAC.com is the username, and the password is capital AC Heat 2007, which therefore you can upload if you don't have it already onto your phone. And now you have Covern's Connect on your phone, and then you can go into the HVAC, you go into Tech Services, and then the HVAC, then you go into Calculators, and then from Calculators you can select Gas Heat with CFM. Then you will type in your output for your furnace, not the input. You could have 100,000 BTU input. It's an 80% efficient furnace, which uses 80%, so if the output is 80%, you type that in. Then you type in your delta T, and it will tell you how many CFMs you are pushing out of that system at that point in time. With the blower motor that you are using, or the blower speed that you are using for cooling capacity. Once you have checked the cooling blower speed to see what CFM the blower is running at this point in time, say it's 1320 CFM, then you need to check to see what tonnage unit you have. I'm gonna say it's a 4-ton air conditioning system. 4-ton air conditioning system is 400 CFMs per ton, is 1600 CFMs. This calculation has told you that you are getting 1320 CFMs out of that system. Now, if you go do your delta T, as soon as you turn the furnace on, your ductwork has not heated up yet. Therefore, the temperature coming out of your vent is not going to be as hot. If you let it run for 15 minutes, your ductwork's going to be hot, you're going to get the proper temperature differential, and then you will have the proper CFM that it's actually pushing out. If you measure your temperature differential early, then it's not as hot coming out, therefore your delta T is not as high, therefore your CFM is not going to be as great, and you will get a false reading. Okay? Once you get your CFM and determine that you got 1320 CFM coming out of that system and you have a 4-ton system, what is your problem? You are not getting enough airflow through that system. Now you need to go through all the diagnostics of why your system is not getting enough airflow in the cooling mode, even though we are working on a heating system. You are going to check everything that affects the supply and return airflow. Filter grills to supply grills and anywhere in between there. Dirty evaporator coils, dirty blower motors, not enough ductwork, insulation falling off in the system, dampers closed, grills closed, whatever, okay? If you have way too much airflow on that system, it's 1320, and you have a 2-ton system, you are now going to reduce the blower speed of that furnace to where it's down to, you may have to use it on low speed to drop it down to 800 CFMs instead of 1320 CFMs. So you drop it down to the red wire, which would be the low fan. You test it again, and then now you get 830 CFMs. And you have verified you do have a 2-ton air conditioning system. That is the correct blower speed for that furnace, for that air conditioning system. Now, since you have been running this system at 1320 CFMs all this time, it was charged at 1320 CFMs, you have now got to go check your head pressure, suction pressure, superheat, subcool, and delta T, and verify that your air conditioning system is charged properly, or you will just totally screw everything up. Okay? You have got to be thorough, and you've got to know why you are doing what you're doing on everything that you do. Okay? That was a lot. Okay? Any questions? All right. Did all that stem from limit switch, guys?
Yeah,
Well, I just get on rants, don't I?
well, it's important because that's one of the most important safety features in the system.
Yep. All right. So a limit switch, A, is okay, tested and reset to the closed position. Open, limit is open and will not reset, replace the switch. Closed, bad, will not open, replace the switch. Number 10, wiring. Check all low voltage and high voltage wiring for burn wires and miswiring, bad connections. Okay, everything works and in good condition. Burned, wires are burnt and charred. Miswired, repair wires, test all operations. So wiring is pretty much obvious. What you're checking, low voltage and high voltage wiring as well. Relays, fan relay, most today are located on the circuit board. If the fan comes on, it's good. If the fan does not come on, check the voltage between C and G. When putting unit on fan on position, other relays in the board will not turn the fan on in different speeds. So on a circuit board, you could have a fan speed of high or medium or low, whatever fan speed you put it on a circuit board that says fan on or continuous fan. So when you put it on the fan on position on your thermostat, it energizes the relay to run it in that particular mode, whatever that fan speed is set at. Older circuit boards, your fan speed would have been the cooling speed, high speed, okay? So as we get more productive today, we can now have different speeds to put the fan in on, or you can just leave it on auto and not worry about it, okay? Fans are very simple. It's either your fan relay is going to be good or it's going to be bad. It's going to be open, closed, or just not working at all. Okay? Okay is relay works fine, blower comes on. Burn, bad connections in the relay and will fry the relay. Bad, CNG energized with no power to blower, change the relay or the board, whichever one consists of. Alright, your circuit board, what are you checking for? Is it mounted properly and secure? Okay, and it works fine. Bad, not sending voltage to the fan relay or other components. Miswired, wires are not in correct location, causing malfunctions to it. Repair it, replace the board, whatever you need to do to get that board running. You also have to know as a technician, how does that board work and what are the functions of the board and where is your voltage going to? Once it goes inside the board, it's lost from there until it comes out to go do something else. Okay? So don't try to diagnose a board and repair a board. There is no repair, you just replace the board. We are not ITT techs. Ignition system we talked about earlier. Spark ignition, glow coil, pilot, all are ignition systems. The board sends voltage through the spark igniter and grounds on the burner, causing a spark. A glow coil, voltage is applied to the ceramic coil, heats up like a heating element. This ignites the gas over it. A pilot could be a standing pilot or a pilot that uses spark ignition and flame rectification before the gas shoots over it into the chamber. We just got finished going over all those ignition systems, right? I just beat the test here. Okay, everything works fine. Burners are, or the pilot ignites. Fair. Low pilot, sparks are not in correct location, old and oxidized. You gotta clean all that stuff so you get the correct sparks out. Poor. Rusted from water or bleach hitting it, does not spark, glow, or ignite. So replace that. Okay. The flame, very important. A good flame is blue and with proper pressure. Look for red tips and lazy, poor oxygen mixture, or no combustion air. If you have no combustion air, what happens to the flame?
It's gonna set off your rollout. It's because the flame, the gas.
It's going to roll out looking for oxygen if you have no combustion air, secondary combustion air. Had a closet system. You look up. Gas furnaces are supposed to have another fresh air pipe coming down on the side of that gas furnace below the burners. That is used for fresh air. If you have a vertical closet and somebody sealed the top when you close the door to the furnace or to the closet, okay, you are closing the secondary air off to that furnace. It's not getting any air if the top's sealed up. Had a unit like that. You open the door, system runs fine. You close the door, you turn around and leave because you don't look up and it just don't occur to you that they don't have a secondary air because you're just used to seeing it. And you get called back, next day and the heater's still not working. You get back out there, you open the door, you turn the heater on, everything runs. No problems. 20, 30 minutes, everything running, no problem. You leave again. They call you back same day. Heater's not working again. Then you go, shit. Look, it's kicking your rollout switch out. Why is your rollout switch popping out? Because the flame's rolling out looking for oxygen because it's used all the oxygen inside that closet and now it's looking for more. So you have to open up the top and allow fresh air to come down or you gotta run a vent pipe down. You're supposed to run a vent pipe down in any way, shape, or form. Okay? That 4 6-inch vent pipe that comes down has got to be strapped to the wall and it has to be higher than the insulation in the attic to allow air to come down, and if they insulate, it's not going to cover it. And below your burners as well. Okay? Lazy. Gas pressure is low. Not enough oxygen mixture. Red tips need to be fixed. So you can adjust gas pressure. You can adjust cleaning the burners, things of that sort with a lazy flame. A lot of times it's gas pressure. Poor flame, high flame rolling out, lazy flame, high pressure from gas valve or very low pressure from the gas valve. watch your flames, guys. Look for red tips on them, okay? And lazy. Pilot. Starts from the ignition system or the old match. The pilot should be a blue flame that you can hear when properly ran. Low gas pressure from clogged pilot pistons will cause a red flame. It may not ignite the gas when the gas valve is open. This could cause a boom. So if you got a very low pilot on an old system and you shoot gas out of it and that pilot is very small, it may take a while for that gas to build up before it hits the flame, and then boom, you will hear a boom, no doubt. You don't want to be standing in front of it either. This could cause a boom if the pilot is too high. Too much pressure, this could trip a rollout switch and start scarring the outside of the furnace walls. So you don't want that pilot. I've seen pilots where they're like 4 inches long. I mean, literally like shooting that long a freaking pilot. Well, the pilot piston was too large and it was just shooting out tremendously. Okay. Pilot assembly, which goes back to the pilot with too big of a piston. Mainly on older units, wall furnaces, floor furnaces, make sure the flame is correct, facing in the correct location. The old assemblies, pilot assemblies, spark igniter assemblies, thermocouple, they have a left, a right, and a center flame throw. Okay, so which one are you at? Is the flame throwing left? Is the flame throwing right? Is the flame throwing center? Based on how that thing is actually made. If you purchase a center and it had a left, then the flame is not being thrown, the pilot is not being thrown over the flame, and you will get a boom maybe. So you can't readjust it, it's thick metal. You just gotta buy the right one. So if you happen to pull a spark igniter, not a spark igniter, but a pilot assembly is what we're going to call it, off of a system, you got to make sure you get the right one. Okay, and we have them here from old school. Heat anticipator. Well, let's go back to the pilot assembly here for a second. Your pilot assembly, okay, pilot performs okay, is okay. Clog, lazy flame, low gas pressure, test low gas pressure test the gas pressures is what I'm telling you it's clogged. Rusted, floor furnaces, pilot assemblies really get rusted and clogged. Almost there. 17 is your heat anticipator. Only relevant on old mercury thermostats. This is the dial on the sub-base of an old mercury thermostat. It has a metal arrow with a metal thin wire with numbers on it. So it looks like this. So you go to your thermostat, you pull the cover off the thermostat. It's one of the thermostats with the little lever on the side of it to go up and down for your heat. When you pull the cover off of it, you look inside of it and it's got a little circle on it. That little circle's got numbers all the way around it. It's also got a metal wire that runs all the way around it. In the middle of it, it's got a little arrow on it, okay? And that little arrow could be facing any way. Now, where the arrow's facing on the left-hand side here, this little arrow has got to be touching this metal. If it's touching the metal, that will allow your heater to come on. If they turn that little knob and it faces this little opening right here, and the back end of it, the arrow's facing up, and the back end of it's facing the opening here, the heater will not come on. If the little wire there is broken, the heater will not come on. If the heat anticipator is set wrong and you put your thermostat on 73, it may run to 76 and shut off. Or it may not come on until it's 68 if the heat anticipator is set wrong. Heat anticipator, what does that mean? It anticipates when the heat should come on. Hence the name heat anticipator.
You're rarely gonna see those though,
Rarely, yeah. Set take the choice you have is to set the heat anticipator, okay? Let me finish reading the first part of it. Alright, this is the dial on the sub base of the old mercury thermostat. It has a metal arrow with metal thin wire numbers on it. Set the arrow to the amperage draw on the amp probe. Maybe 0.4 amps, not 4 amps. If the metal wire ring is broken, heater will not come on. If the back side of the arrow is not touching the wire, heater will not come on. We have to set the heat anticipator, and how do you set the heat anticipator? You take the sub base off of there, and then what are you left over with? You're left over with the base of the thermostat, which has common W, Y, G, what else? W, Y, G, R. There's the other one I'm missing. The power. How about that? You have to take your meter and go W, R. Then you're going to take your meter over here that's got an amp probe on it, and you're going to run that wire through your amp probe, and you're going to read very, very, very low amperage. 0.04 amps, 0.02 amps, 1.2 amps, okay? When you jump off W to R, you are running your gas valve, you are running your heat sequencers. You have to let the entire system come on and run. Whatever your amperage is reading on here is what you set your heat anticipator to point to. Then that will tell you, and then plus your thermostat's got to be level. Then that will tell that heat anticipator when to turn on and turn off. If the heat anticipator is set wrong, it heats up the helix coil inside of there, which pushes the helix coil, which pushes the mercury bulb over. Too fast or too slow, whichever way you set it wrong. Okay? Digital thermostats don't do any of that. Alright, other. Check your CFM as we talked about earlier. If you have an electric heat system, you will do the same thing as we talked about with the gas heat system. You will take the blower speed from your electric heat system if it is different from your heating system, and you will put the blower speed for the cooling on whatever relay the heater blower speed is on. Let the heater speed dangle, run your electric heat system, get your delta T, go to the Cobrig's app, HVAC, then you're going to go to electric heat, CFM, and then you're going to put in the KW, and you're going to put in the delta T, and it's going to give you your CFMs. Then you are going to take that blower back off and put your heating one back on, and put your black one or high speed back into cooling mode, and now you know how many CFM that the cooling system is actually providing. I don't care about the CFM on the heating system. And the reason I don't care about it is we have 2 weeks of hot weather, cold weather. With those 2 weeks of cold weather, I do care what your delta T is in your heating mode, meaning what should it be? Between 30 and 55 degree delta T in the heating mode. If you're running 20 degree delta T in the heating mode with an electric heat system, what do you need to do? Normally, if that is happening, what is happening is that air handler only uses one blower speed. Many air handlers use one blower speed for cooling, the same blower speed for heating. When they do that, you have got to be ingenious. You have got to sometimes add a relay to the system. When you add a relay to the system, you can now run the heating system with a low fan, and then the high fan run for cooling. If you are running the low fan at this point in time, or high fan at this point in time for your heating, and your delta T is 20, we need to lower your blower speed so that your delta T for your heating does not, or does come up. If I have a 15 kW electric heat system and that blower motor runs on high fan, which again, most of them do, 15 kW heat with a blower speed pushing, I'll say 1600 CFMs of airflow over it. 15 kW heat is how many BTUs? 3413, 3.413 BTUs per kilowatt multiplied by 15. So if I multiply it by 10, that's going to give me 34,130 BTUs. If I take that in half, that's 15, that's 17,000 BTUs, right? In that ballpark. So let's just carry that 130 right there, and then we'll go 11, 1, now it's 51,000 BTUs, okay? So that's 15 kW heat. If you are running a 10 kW heat system with a blower speed running at high speed for 48,000 BTUs in a cooling mode, you want, and you're getting a 20-degree delta T there, you want a 30 to 55 delta T in your heating mode, which means you have to lower your blower speed down to make the heating elements get hotter. How do we do that? You got a blower motor here, and I am using L1 right here, okay? That's my power coming into that motor. Here's my other power coming into the motor because it's L2, which is, I'm sorry, it's not going in, well, it is going into the motor, L2. You've got a relay on here, and then that relay is what's actually, I am writing this wrong, god damn it. L1's coming in here, okay? And then it's coming in here into a relay, which therefore energizes your fan, because I got L2 coming over, I'll make a 4 with it, and L2 coming over here, which is now energizing my motor. Now, this is a black lead, and we're going to call that high speed. I'm going to call this one the yellow wire coming over here attached to L2, which black and the yellow wire feeds my 220 volts, which feeds my blower, and my blower motor is running. I have a red lead here, and this lead is taped off and not being used. So I want to lower my blower speed for the electric heat system so that my 10 kW heat now gets a lower blower speed over it and heats the home better. Because I don't have a big enough wire to run 15 kW heat, so I have to run a lower blower speed so the existing 10 kW heat is going to work better. What if this house is a old New Orleans home with single pane windows and above ground house and no insulation in the floors? Then the answer is you need 15 kW heat. They need to run a new wire. And they need another heat strip. Okay? In this case, it's a slab house, 1,500 square feet, but we just happen to use 10 kW heat. But the blower motor spins too fast, so here's what we have to do. This black wire for my high speed is energized by a fan relay, and this fan relay, I'm going to call this, for argument's sake, my G and common, which energize and close this switch, which turn my fan on. Okay? So, if I go in here and I add a 9293 relay, and my coil's at the bottom, and I'm going to connect W to this side, and I'm going to get common on this side. And a 9293 relay is a normally open, normally closed switch. So what I need to do now is I need to go and cut this black wire right here. And I need to take this and I need to power it into here. Then I need to take this black wire and I need to run it right around over here and it be normally closed. Did I change anything of how the way this system works at this point in time? I did not.
No.
Because all I did was hooked it to a normally closed switch. Did not change a thing.
No, you didn't attach the red to the new relay.
Not yet. I will. My red wire now comes and attaches to here. When I go turn my air conditioner on, I am not energizing W, right? I run on high fan. If I just turn my fan on, I'm not energizing W, I run my high fan. When I turn my heater on now, I energize W, which closes this switch and opens this switch, and I run on low fan. Now I have less airflow over my 34,000 BTUs, and I have a hotter air coming out and a bigger delta T. Make sense?
Yeah.
So this is the first part, the end of some part in electric heat, some part in gas heat, but this is the first check. We have just finished the first 16 when we got 2 other on there until we get to the other parts of the heating check, which we'll do electric heat on another video and finish this off. Are there any questions on the gas heating system and what we need to check with the gas heating systems? I'm glad I finally put all this on video so I never have to do it again. I'm just gonna say, sit here and watch the videos.
Well, it's easy when if you want to make it sink in. I mean,
Any
you just
questions,
pull it
guys?
out.
Self-explanatory?
Yeah.
Okay.
Oh, it's self-explanatory, but you did a good job explaining
You
it.
to send that to my email?
You have to produce it.
You go through a vigorous editing process.